Hello, hi everyone. Welcome to the Student the Brand. This is our Siva sir. Today I'm going to discuss about light reflection and diffraction. Light reflection and diffraction chapter. Light reflection and refraction chapter. So, light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. When light incident on the surface, it reflects back. Okay. Light reflection and diffraction chapter. So I'm going to discuss about light reflection and diffraction chapter. Okay. Now you can see here light reflection and diffraction chapter. Light reflection and refraction chapter. Refraction. When light is incidenting on the surface, after reflection, it moves in the same medium. So after reflection, light is a form of energy which gives the sensation of sight. Already we know that. Okay, now here. So I'm taking the surface here. This is a plane surface. It's a plane surface. So this is incident ray, reflected ray, incident ray, reflected ray, and normal line. So I'm taking this a normal line. The angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. And the deviating surface. The deviating surface. Okay. This deviating. Okay, now that is nothing but undeviated line. Undeviated line. Normally, if the light ray passes in homogeneous medium, moves in a straight line path. In homogeneous medium, light moves in a straight line path. Yes or no? Yes. So in a homogeneous medium, light moves in a straight line path. 1 minute. The angle between incident ray and this incident ray, reflected ray, normal line. Angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called angle of reflection. So this is the undeviated line. So light, okay. So without deviating, light passes through the surface. In case, so we assume that light ray moves in a straight line path. If this surface is not there, light ray moves in this direction. Okay. So the angle between reflected ray and undeviated line is called angle of deviation. So this is called angle of deviation. Incident ray normal line, reflected ray, normal line. Angle between incident ray, normal line is called angle of incident. Angle between reflected ray, normal line is called angle of reflection. Angle between undeviated line and reflected ray, angle of deviation. Angle of deviation. Done. Now here you can observe one thing, that is this linear angle is 180 degrees. Linear angle is 180 degrees. So the linear angle is 180 degrees. We know that. Okay. So on the linear line, what are the angles are there? What are the angles? Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Right? Now, laws of reflection. We know laws of reflection. Laws of reflection. Laws of reflection is nothing but point number 1, incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies in the same plane. Incident ray, reflected ray, normal line lies in the same plane. So angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Loss of reflection. Loss of reflection is nothing but incident ray, reflected ray, normal line lies on the same plane. And angle of incident is equal to angle of reflection. So this is about the loss of reflection. The bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. Incident ray, reflected ray, normal line lies on the same plane. Angle of incident is equal to angle of reflection. So these two are laws of reflection. These two are called laws of reflection. Laws of reflection. Now we will discuss about regular reflection and irregular reflection. Regular reflection and irregular reflection. So what is regular reflection and what is irregular reflection? Regular reflection takes place on smooth surface. So I am taking the surface like this. This is the surface. So regular reflection. So regular reflection. So incident light rays are parallel to each other. Incident light rays are parallel to each other. So I am taking here. These are the incident light rays. 1, 2, 3, 4. Okay, so 4 incident light rays. So incident light rays are parallel, and reflector light rays. Reflector light rays are also parallel to each other. Incident light rays are parallel to each other. Then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. Incident light rays are parallel. Reflector light rays are also parallel to each other. Incident light rays are parallel to each other. Then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. This type of reflection is called regular reflection. Coming to irregular reflection. Irregular reflection. So irregular reflection I am taking here. Irregular reflection. These are the irregular reflection. Okay. So now you can observe here. These are the incident light rays. 1 and 2 and 3 and 4. Okay. So then this reflector light rays. You can observe these reflector light rays are moving in different directions. These reflector light rays are moving in different directions. So incident light rays are parallel, but reflector light rays are not parallel to each other. So this type of reflection is called irregular reflection. Irregular reflection. Irregular reflection. Okay. So regular reflection and irregular reflection. In regular reflection, Irregular reflection, incident light rays are parallel, then reflector light rays are also parallel to each other. This type of reflection is called regular reflection. Coming to irregular reflection, incident light rays are parallel, but reflector light rays are not parallel to each other. Reflector light rays are not parallel to each other. So, this type of reflection is called irregular reflection. Regular reflection takes place on smooth surface. Best example, we can take a plain mirror we can consider, and one more thing, so we can also take still water. Yes, very good, Mahesh. Water surface irregular. Mahesh, actually, still water. Yes, water and moving condition also irregular, but still water. So what is that? Constant, like it is not in moving condition. Like we can say static position. Okay. What is that static position? Still water. That is called still water. Yes, that time we can say regular reflection. Irregular reflection, yes, as you said, moving condition also we can say turbulent flow like this, water flow. That time the surface is not regular, so that is irregular. There, then irregular reflection takes place. Even wall also, best example on wall, irregular reflection takes place. Even you can see the, even you can observe the paper. Paper also we can take. Yes. So concave mirror and convex mirror explained is always. Yeah, SNS creative, I can understand. Because I explained definitely in a sequence we are going, right? I will explain concave mirror and convex mirror. So definitely I'll explain. Okay. So regular reflection and irregular reflection, regular reflection and irregular reflection. So I hope it is very clear. Now we will discuss about image and object, image and object, image and object. Image and object. Okay, so here you can observe very important concept. It is very important concept. So you can observe here. So I'm taking the plane mirror like this, plane mirror. Okay, so this the object I'm taking, like we can take the point object. So point object, so light rays are coming from that object. So this the object, light rays are coming. So one light ray and another light ray. These light rays are reflected and these light rays are reflected. So we can observe, if you are extending these light rays and if you are extending this light ray, image will form. Okay, so here you can observe, here these are the light rays are coming from one point. So this is called real object, from that object light rays are coming. After reflection, those light rays are moving away from the principal axis. If you are extending this reflector light rays, reflector light rays are meeting at one point. Their image is forming. That is called real image. Virtual image. Because sir, why you are calling it is a virtual image? Because we are extending the reflector light rays. So reflector light rays are meeting at one point. So that's why it is called virtual image. The extended reflector light rays. That two dotted lines, extended reflector light rays are meeting at one point. Their image is forming. That is virtual image, right? So now we can take the plane mirror here. So I'm considering like this. And here also these are the incident light rays and these are the incident light rays. So after reflection, those light rays are meeting at one point here. Okay. So if you are extending the incident light rays, here you can observe carefully. If you are extending the incident light rays, that is a virtual object, and here is the real image. Sir, what is the difference between real object and virtual image and real image? Here the point is, here you need to understand clearly, you have to observe carefully. So light rays are coming from one point. So after reflection, light rays are moving away from the principal axis. Here we are extending the reflector light rays. Extended reflector light rays are meeting at one point. Their virtual image is forming. Here you can observe directly reflector light rays after reflection. So incident light ray, reflector light ray. After reflection, reflector light rays are meeting at one point. So these are the reflector 1, 2. Reflector light rays are meeting at one point directly. Reflector light rays are meeting directly at one point on the principal axis. So that is called real image. Here we can observe incident light rays. Okay, extended incident light rays are meeting at one point. Extended incident light rays are meeting at one point. Their virtual object here and a virtual image here. I hope it is very clear. So real object and virtual image, real image and virtual object. So by observing these two diagrams, we can conclude that so that is you can see here, okay. So object and image. Object is real, image is virtual. Object is virtual, image is real. Yes or no? So once again check here. Object is real, image is virtual. Object is virtual, image is real. Okay, so this is about the object and image. Okay, so object is real. This is a real object, virtual image. Virtual object, real image. So we can conclude that by saying this one, right? Now, so we will discuss about one more, that is nature of the image formed by the plane mirror. So how we can observe that one? So you can see here. So I am taking the object here. So nature of the image formed by the plane mirror. So I am taking the plane mirror like this. This is a plane mirror. Okay. So here I am considering the principal axis. So this is the incident ray. So one light ray I am taking like this. So it will be reflected. Another light ray I am taking like this. So normally when light ray is passing along the normal line, it reflects, it retraces its original path. So when light ray is passing along the normal line, it retraces its original path. It reflects into the same path. Okay, it moves in the same direction. So like this. So here this line I am taking and one more light ray I am taking like this after reflection. So that will be moving away from the principal axis. Okay, now so one more light ray I am taking like this. So as I said, same process. If the light ray is passing along the normal line, it reflects back. And here also I am considering here this is the incident ray, reflected ray, and this one is incident ray, reflected ray. So if you are extending this one, okay, so we have to extend the reflector light rays. The extended reflector light rays are meeting at one point. So now you can observe here. Okay, now okay, done. I hope it is very clear to you all. Is it clear? If it is clear, let me know. Okay, done. So if you are extending these light rays, and if you are extending these light rays, or if you are extending light rays, like this, okay. we are assuming those light rays are meeting at one point. Virtual image, how can we understand where it will form? By extending the reflector light rays after reflection. So we are extending, their virtual image is forming. We are assuming those light rays will meet at one point. Okay, So this is the object A, B, and this one is the A dash and B dash, A dash and B dash. So here one point, yes, this is a plane mirror. First one is object is real, image is virtual. Object is virtual, image is real. As I said before. Okay, second one, object distance is equal to image distance, and the height of the object is equal to height of the image. So be very clear here. So object is real, image is virtual. Object is virtual, image is real. Object distance is equal to image distance. So this is the object distance, and this one is the image distance. Image distance. Object distance is equal to image distance. Or what is object distance? The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. So object distance is equal to image distance, and the height of the object is equal to height of the image. Height of the object or size of the object is equal to size of the image. Okay. So this is about plane mirror, nature of the image formed by the plane mirror, and magnification of the plane mirror is +1. Magnification of the plane mirror is +1. Okay, I hope it is very clear. I hope it is very clear. I hope it is very clear to you all. So magnification of the plane mirror is +1. Magnification of the plane mirror is +1. Understood? So once again, object is real, image is virtual. Object is virtual, image is real. Object distance is equal to image distance. Height of the object is equal to height of the image. Height of the object is equal to height of the image. Okay, and magnification of the plane mirror is +1. Magnification of the plane mirror is +1. So this is a very important question. So 3 marks question expected for board exam. 3 marks question expected, and also many points are there. MCQs points. Object distance is equal to image distance. Height of the image is equal to height of the object, and also magnification is +1. So very important all these points. Now we will discuss about spherical mirrors. So the mirror which in the form of curved shape is called spherical mirror. The mirror which in the form of spherical or curved shape. Okay, so that is called spherical mirror. There are two types of spherical mirrors: concave mirror and convex mirror. Concave and convex mirror. Okay, now you can observe here. Concave mirror, spherical mirror, the mirror which in the form of curved shape. The mirror which in the form of curved shape is called concave mirror. The mirror which in the form of curved shape is called concave mirror. So here I am taking spherical mirror. Spherical mirror. The mirror which in the form of curved shape is called spherical mirror. So reflection takes place. Reflection takes place inward, concave mirror. Reflection takes place outward is called convex mirror. Sorry that. So the mirror which in the form of curved shape. The mirror which in the form of curved shape is called spherical mirror. Spherical mirrors are divided into two types: concave mirror and convex mirror, based on the reflection. So if reflection is taking place inward, that is called concave mirror. The reflection of the mirror takes place inward, so then that is known as concave mirror. Reflection takes place outward is known as convex mirror. Okay, so reflection takes place inward, concave mirror. Reflection takes place outward is called convex mirror. Convex mirror. So here you can observe. Okay, so here only light reflection and diffraction chapter will be served. Okay, so only that chapter only will be provided. So if you want to ask doubt, you can ask only in that only. So you can add in the sense you can ask questions. Then your answers will be delivered to you. Okay. Then here I am taking like this. So this is the concave mirror. So the mirror, so whose reflection takes place? the mirror reflection takes place. Mirror reflect light rays. Mirror reflect light rays inward. So that is called concave mirror. Reflection takes place inward is called concave mirror. Reflection takes place outward. Reflection takes place outward. So here I am taking, so light rays are incidenting on it. Those light rays are reflected like this. Okay. So this reflection is called convex mirror. This mirror is called convex mirror. This mirror is called concave mirror. Concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Concave mirror. Concave mirror. So is also known as converging mirror. Converging mirror. Converging mirror. And convex mirror is also known as convex mirror. Convex mirror is also known as diverging mirror. Diverging mirror. Understood or not? Understood or not? Concave mirror is also known as converging mirror, whereas convex mirror is also known as diverging mirror. Diverging mirror. Concave mirror, converging mirror, convex mirror, diverging mirror. I hope it is very clear to you all. So this is about concave and convex mirror. Next one, so we will discuss about one more. We'll discuss about one more. That is so now you can see. So we'll discuss about terms related to spherical mirror. So that is about concave mirror. Terms related to spherical mirror. Terms related to spherical mirror. Now you can observe. So I'm taking like this. Okay, so this is a concave mirror. Concave mirror. So it is a part of the sphere. It is a part of the sphere. The center of the imaginary sphere in which mirror is a part. The center of the imaginary sphere in which mirror is a part. The center of the imaginary sphere in which mirror is a part. The midpoint of the mirror is called pole. Midpoint of the mirror is called pole. The center of the imaginary sphere in which mirror is a part is called center of curvature. The midpoint of the mirror is called pole. The line joining of center of curvature and pole is called the principal axis. The line joining of center of curvature and pole is called the principal axis. So the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to radius of curvature is center of curvature to pole. The distance between center of curvature to pole is called radius of curvature. So after reflection, light rays are meeting at one point on the principal axis. After reflection, those light rays are meeting at one point on the principal axis called focus. So the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. Okay. And width of the mirror is called aperture. Width of the mirror is called aperture. Once again, listen carefully here. So point number one. Point number one is, so center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. Midpoint of the mirror is called pole. Midpoint of the mirror is called pole. Okay. Midpoint of the mirror is called pole. So the distance between center of curvature to pole is called radius of curvature. The line joining of center of curvature and pole is called principal axis. After reflection, lights will meet at one point on the principal axis, that is called focus, or simply we can say principal focus. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. Okay, na? So yes. I hope it is very clear. So the distance between focus to pole is called focal length. Center of curvature, pole, and focal length. So principal focus, and fourth one is focal length. Fifth one is principal focus. Principal principal axis, and sixth one is principal axis, and sixth one is radius of curvature, seventh one is aperture. Aperture is nothing but reflecting surface. Aperture is nothing but reflecting surface, so where reflection takes place. Okay, so I hope it is very clear about this. Is about terms related to spherical mirror. Terms related to spherical mirror. Now we will discuss about ray rules. Ray rules of concave mirror and convex mirror. Ray rules of concave mirror and convex mirror. Ray rules of concave mirror and convex mirror. So now you can observe. So ray rules. So now we are taking here. This is a concave mirror. Concave mirror. So pole, focus, center of curvature, pole, focus, and center curvature. So one light ray passing. So this is the incident ray. After reflection, light ray passes through focus. This is the first point. Coming to the second point. So here I am taking like this: pole, focus, and center of curvature. So light ray is passing through focus. After reflection, moves towards infinity, and so center of curvature. Coming to third one, light ray is passing through center of curvature. This is the pole, focus, center of curvature. Light ray is passing through center of curvature, so it moves in the same direction. Coming to the fourth one, so this is the pole, focus, and center of curvature. Light ray is incidenting at the pole, so it reflects back into the same medium. So same medium. I hope it is very clear. So once again, so light ray is coming from infinity after reflection. After reflection passes through focus, light ray is passing through focus. After reflection moves towards infinity, light ray is passing through the center curvature. It retraces its original path. Light ray is incidenting at the pole. It reflects back into the same medium. Okay, so these are the four ray rules of concave mirror. So coming to the convex mirror, So we'll discuss about convex mirror. So now convex mirror, first one, convex mirror, pole, focus, center of curvature. Light ray is coming from infinity after reflection, moves, passes through focus. Second one, light ray is passing, so pole, focus, center of curvature. Light ray is passing through focus. After reflection, moves towards infinity. And coming to third one, light ray is passing through center of curvature. So this is the pole, focus, center of curvature. Light ray is passing through center of curvature. It retraces its original path. So I am taking like this. So it retraces its original path. And coming to the fourth one. So this is the fourth one. So here is the pole, focus, center of curvature. Light ray is incidenting at the pole. It reflects back. Okay, so these are the four ray rules of convex mirror. So now we will discuss about image formations of concave mirror and convex mirror. Convex mirror. Image formations are very, very important. Make sure that you are learning all these points. Okay. So first one, First one, first image formations for concave mirror. So I'm taking the concave mirror like this, concave mirror. So this is the pole, focus, center of curvature. Light rays are coming from infinity. Light rays are coming from infinity. After reflection, these light rays are meeting at one point. So after reflection, so object is at infinity, image is forming at focus, nature of the image is real and inverted, and size of the image is highly diminished. So that is the first one. Coming to the second one, light ray is placed beyond center of curvature. So pole, center of curvature I am taking, light ray is placing, object is placed beyond center curvature. Object is placed beyond center curvature. How many light rays are required to form the image of the object? Minimum 2 light rays. So one light ray I am taking like this, it passes through focus. Another light ray I am taking here, so it passes through center curvature. Okay, so those light rays will meet. So in between C and F, So nature of the image is, object is placed beyond center of curvature. Image is formed between C and F. Nature of the image is real and inverted. Size of the image is diminished. Compared to the object, image size is decreased. Object is placed beyond center curvature, image will form between C and F. Nature of the image is real and inverted, and size of the image is diminished. So these are the two image formations. Next one, so we'll discuss about remaining image formations. So be ready for it. Okay. Two image formations. So coming to the third one, object is placed at center of curvature. So third one, if you are taking here, object is placed at center of curvature. So this is the pole, focus, center of curvature. Object is placed at center of curvature. So one light ray I am taking like this. It passes through focus. Okay, so this is the focus. And the light ray is incidenting at the pole, so it reflects back. Okay, so here I am taking. Okay, object is at C, image is formed at C, nature of the image is real and inverted, size of the image is same size. Because object is placed at center curvature, image also will form at center curvature itself. And coming to the fourth one here you can observe. So pole, focus, center of curvature, object is placed between C and F. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So one light ray I am taking like this, it passes through focus. So another light ray I am taking like this, incidenting at the pole. So it reflects back. So now you can observe here. So the image will form here. Okay, object is placed between C and F. Image will form beyond center of curvature. Beyond C. Nature of the image is real and inverted. Size of the image is enlarged. Compared to the object, image size is increased. Okay. So these are the two image formations. Coming to the fifth one, object is placed at focus. So that we have to discuss. Now you can see. So fifth one, object is placed at F. So pole, this is the pole, focus, center of curvature. Object is placed at F. One light I am taking like this, it passes through focus. Another light I am taking like this, it will be. So object is at F. Image also will form at infinity. Nature of the image is real and inverted and highly enlarged. Coming to the sixth one, object is placed. So pole, focus, center of curvature. Object is placed between F and P. One light ray I am taking like this, so it will be reflected back. Another light ray. So if you are extending these light rays, so the image will form here. So the image will form behind the mirror. So behind the mirror, nature of the image is virtual, erect and enlarged. Compared to the object, image size is increased. Compared to the object, image size is increased. I hope it is very clear. So this is about concave mirror image formations. So now coming to the convex, only two cases are there in convex mirror. So in convex mirror, only two cases are there. Case 1. So convex mirror. Pole, focus and center of curvature. Object is placed at infinity. So one light ray I am taking like this, another light ray. So if you are extending these light rays, the image will form at object is at infinity, image is forming at focus. Nature of the image is virtual and erect. So virtual, erect and highly diminished. Virtual, erect and highly diminished. Virtual and erect, highly diminished. So that is the first one. Coming to the second one. So here I am taking like this. This is the pole, focus and center of curvature. Object is placed anywhere between P and F. One light I am taking like this. So another light ray is incidenting. So if you are extending these light rays, so these light rays will passes. So here you can take. So the image will form between P and F. So object is placed between P and infinity. Image will form between P and F. Nature of the image is virtual, erect and diminished. Compared to the object, image size is decreased. Okay, so these are the two image formations of convex mirror. So next one we'll discuss about sign conventions. Sign conventions we'll discuss. So based on that one problem formula also there. So refraction we have to discuss. Refraction also pending is there. So we need to do problems also, not only concept, problems also we need to discuss. So here I am taking the concave mirror. Concave mirror I am considering here. So this is the pole, focus and the center of curvature. So all measurements we have to take from the pole in the direction of incident rays. Object distance, all distance are positive. Opposite to incident rays, all distance are negative. So above the principal axis, all distance like height of the object and height of the image positive. Below the principal axis, height of the object and height of the image negative. Okay. So above the principal axis, height of the object and height of the image positive. Below the principal axis, height of the object and height of the image is negative. Okay, all measurements we have to take from the pole. So mirror formula 1 by F equal to 1 by V plus 1 by U. Magnification is minus V by U. So these are the concepts related to light reflection. Light reflection. So I'll sing you one song. I'll sing one song related to sign conventions. New Cartesian sign convention. New Cartesian sign convention. All distance are measured from the pole. Distance are positive along the instant rays. Distance are negative opposite to instant rays. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign a convention, all a distance, measure from the pole, distance positive, along the instant trace, distance negative, above the principal axis, distance negative, below the principal axis, new Cartesian sign a convention. So this is about new Cartesian sign conventions and light reflection and diffraction. So I hope it is very clear. So if you want classes, subject related topics and different subject classes or tuitions, if you want, contact to this number 984981280. So most experienced faculty members will take the demo classes. Once you can attend the demo classes, so we are going to start demo classes. So in that you can observe the demo class, you can see the demo class. So if you want the classes from those teachers, so they will available to you. So definitely they will take the classes. Okay, so you can get coaching from best faculty members and best experts. Okay, so right mentors for you all, right? So daily at 9 o'clock or 9 to 9:30, so I'll inform to you. So soon I'm going to start, so be ready. Those who are interested, I'll be creating one post related to this one. Those who are interested to take the no, join to the demo classes, not only physics, right from 6th to 12th, right from 6th grade to 12th grade. So all subject teacher, all subject faculty members are available. Okay, so every day one demo classes it will be going on. So soon it will start, not so it's not too long, so maybe 1 or 2 days, within 1 or 2 days. So today, so I hope it is Thursday, right? Yes. So we will get by Sunday or Monday. I'll let you know. So by Sunday or Monday, we will let you know the timings. So definitely, you will just join to the demo classes, attend to the demo classes. So observe the demo classes, how the faculty members are teaching. So great experienced people are there. So nearly 5 years, 10 years, 12 years, 13 years. So like this, those many experts are there. So those are going to take demo classes. So you can observe the demo class, you can watch the demo class, you can see the demo class. If you like the demo class, so let me know, so you can get training, get coaching from them. Okay, so we'll see in the demo class. So I'll let you know. So 1 or 2 days, based on your interest, on how many classes, how many students are there from a particular class, we will check all those things. Okay, so based on that one, we'll start the demo classes. So soon I'm going, within 1 or 2 days, we are going to start a demo class, right? Demo classes. So every day one subject we are going to start. Those who are interested, you can join to the demo class. If you like the class, if you like the content, if you like the teacher explanation, so you can get the coaching from them. Okay, so if you like this explanation, if you like this content, if you like this channel, please do like, share and subscribe to Student the Brand. You can inform to your friends, you can share to your friends, you can ask your friends to join to the class and attend the demo class. Soon we are going to start the demo class. Attend the demo class. So thank you so much for joining, attending, listening and giving an opportunity to teach you. Thank you so much. This is your Shiva sir from Student the Brand signing off. So if you want demo classes, if you want to join to the demo class, those are interested to join to the demo class, so let me know through this number. So WhatsApp number is there. You can send a hi and you mention your class. Okay, so based on that one, I will provide the Zoom link to join to the demo class. I will provide the Zoom link so you can join to the demo class. So guys, say hi to this number. So mention your class, mention your name. Okay, thank you so much. So see you soon in the class. Thank you.